everyone, and welcome to another episode of How Many Tabs Are Open on Mr. John's Computer? 246. Not too bad. Small amount of tabs for a small amount of assignments this week. So you had your 2 assignments yesterday. Remember, since you have so few assignments this week, if you're missing anything from previous weeks, please go back and take the time that you have this week to make up some of that stuff because I have not seen a week where you've only had one math assignment and one science assignment per day. So this is an excellent time to go back and check if you're in my block, if you need to finish any of your quizzes. Remember, there's a list of every single quiz that you've taken this year or this 9 weeks right here. So if you need to make up your January 22nd math quiz, then you click on the January 22nd math quiz, and well, it'll send you the redirect notice. But there you go. So just a reminder that there is a quiz list for you right there. All right, so today's assignment is Thursday, February 25th, and we're doing fractions review part 2. Let me go ahead and close some of these things out because I already opened that. All right, here we go. So, same or different? How are these the same? How are these different? Okay, so once again, obviously you can you can go very very bare bones with this and say I noticed that these are two math problems. That is not really bringing in the concepts that you're learning in 5th grade. So really think about the things that you're like the vocabulary you're using this year that you didn't use last year and things like that. I know that in 4th grade you did not divide whole numbers by fractions last year. So even saying that you're dividing a whole number by a fraction, that's being specific, all right? Or just talking about pictorial representations and numerical representations and really using that vocabulary that's going to kind of stick with you through the next few years. All right, so what we're looking at, let me go ahead and open up the OneNote so we can talk about it. What we're looking at here is a pictorial representation of a math problem and a numerical representation of the same math problem. Go figure. So the first thing that we need to do is let's go ahead and let's make our picture. All right. So the main thing you got to realize here is this picture is the math problem after it's been done. Okay. So what you have to realize is this is one hole and this is one hole to start with because there is 2 holes to start with. All right. So this is your pictorial. They sometimes say pictorial. So pictorial. And what we're basically looking at is we're looking at one hole and 2 holes. All right. So those are the solid lines. All right. The solid lines show that that is a hole, one hole. All right. So if we're going to label this is 1 and this is 1. All right. So 1 plus 1 is 2. So what happened next is they did a little dashy dashy choppy choppy. All right. So when you see a dashy dashy line, that means that they are doing a choppy choppy. All right. So what they have done is basically they are taking their 2 holes and they are chopping them up into 1, 2, 3 pieces, 1, 2, 3 pieces. So whenever you see those dashed lines, that means that they are cutting something up. All right. So they just cut this hole into 3 pieces. They cut this hole into 3 pieces. All right. So basically, you are looking at 2 holes divided into 1/3 size pieces because this is 1/3. Oops. This is 2/3. This is 3/3. So that's why this is one hole. This is 1/3. This is 2/3. This is 3/3. That's why this is also a hole. So we put the one hole and the one hole together to get 2, and then you divided it into thirds. So let's actually do this problem, okay? Because here's the numerical representation, and let's actually calculate and figure out what we're looking at over here. All right, so we had 2 divided into 1/3 size pieces. So remember, for division, same as multiplication, you have to turn your whole number into a fraction. How do you turn your whole number into a fraction? T-pose it. Remember, T-pose is just code for you're basically making a 1 as the denominator. right? So, um, whenever you need to turn a fraction or a whole number into a fraction, you just put the line of the fraction and a 1 as the denominator. That's saying you have two whole things, but it's saying it is a fraction. It's basically the improper, unsimplified version. All right. So, next thing we're going to do is keep, change, flip, because that is our division of fractions rules. So, keep, change, flip. You keep the first fraction exactly the same. You change the sign from division to multiplication. And you flip that second fraction, finding the reciprocal, you put the denominator on top and the numerator on bottom. All right, so now that we've done keep, change, flip, we now have our multiplication of fractions problem. And to do that, it's just remember top times top, bottom times bottom, and then we'll have to simplify, right? So 2 times 3 is 6. 1 times 1 is 1. So this is 6 over 1. That is improper because we have a larger number as the numerator than our denominator. So our whole, if we simplify this, 6 divided by 1, remember all fractions are division problems. So this is basically 6 divided by 1. If you had 6 cookies and you divided them amongst yourself, you would still have 6 cookies, right? So the answer is 6. And if you look over here, how many pieces do we have? 1, 2, 3, 4, 5, 6. So that's how the pictorial representation matches the numerical representation. Is the answer was how many pieces we ended up with when we cut two holes into 1/3 size pieces. So we took two holes, we divided it into 1/3 size pieces, and we got 1, 2, 3, 4, 5, 6 pieces. There's 6 1/3 size pieces. Over here, we did it as the numerical representation, which doesn't show us the picture, so it's a little bit more abstract. But what we did is we said two wholes divided into 1/3 size pieces. We turned the whole number into a fraction with a 1 as the denominator. We did keep, change, flip to make sure that we can solve our problem. Remember, to divide fractions, you're basically multiplying fractions, but you just have to flip the second fraction. So then we found out that there were 6 pieces in total, which matched our picture. All right, so if we go back to our discussion, once again, remember, all 4 discussion stems are necessary for full credit, so please use all 4. If like just watching the videos should allow you to have some reference of things that you can say. So once again, I noticed that this is 2 representations of dividing whole numbers by fractions, because what we did is we divided a whole number by a fractional piece, and we divided these 2 wholes into 1/3 size fractional pieces. All right, they are the same representation of value. So this shows a pictorial representation of 2 being split into 1/3 size pieces. This is the numerical problem, 2 divided into 1/3 size pieces. They are different because this one will allow us to get the answer by doing the algorithm. This one allowed us to get the answer by just counting how many pieces there were. All right, so one is very visual and one is very abstract. I wonder. I wonder if they show chopping in any other way other than dashed lines. For the most part, as a teacher, all I've seen is dashed lines, but every once in a while it might not be a dashed line. You just got to look for differences. If you have a color picture, sometimes they do colored lines, things like that. So I wonder how else they might represent cutting things up in pictorial form. All right. So there are some help with your stems. So feel free to use any of those if you need to. And that should be it. So this is just a little review on dividing fractions. Remember, keep, change, flip. It's the difference between dividing fractions and multiplying fractions. But basically, dividing fractions uses multiplying fractions as part of the process. So um, definitely talk to your teachers if you have any questions. I hope that you have an absolutely wonderful day. Like and subscribe. I can't even say subscribe. Like and subscribe. And I hope that you have a wonderful day. I think I already said that anyway. Okay, I'll see you later. Bye.